Hello, everyone. Dr. Daniel Barth here, coming to you pre-recorded for this special global star party on dark matter. And tonight, I'm here to throw a wrench in the works for everybody. I'm here to talk to you about an alternate theory to the dark matter concept. This is called MOND, or Modified Newtonian Dynamics. This theory was invented by a fellow named Milgram, who's a physicist from Israel. And as someone pointed out when I mentioned this topic to Scott, someone says, oh, but that's been disproved and nobody likes it anyway. Well, allow me to say that the first statement isn't true and the second one isn't relevant. Just a few words for you. Let's start out with a few. Phlogiston? How about luminiferous ether? How about the great granddaddy of them all, the geocentric Earth, or even the planet Vulcan? All of these ideas were brought forward into the scientific workspace and proposed as theories for the behavior of nature. In every case, each of these theories was considered the correct idea by scientists and mathematicians the world over. They were written about in textbooks, they were taught in schools, and oh yes, they all have one other thing in common. They were all wrong. Now, when we take a look at the idea of the geocentric Earth versus the heliocentric system, these two theories existed in the scientific workspace for over 2 millennia. These two theories existed side by side, and by the time you reach the 1500s, scientific opinion had shifted enormously to one side. In this case, it shifted to the geocentric Earth. Everybody believed it. Everybody taught it. Matter of fact, it was so well thought of that people who supported the kooky heliocentric theory were considered at best cranks and crackpots, at worst heretics. Ask Galileo. Well, the problem is, friends, that the heliocentric and geocentric theories existed side by side for so long because no one could prove whether one theory or the other was correct. One was certainly a lot more popular and a lot more well-liked, but it wasn't true. Only when Galileo invented the true astronomical telescope and observed the phases of Venus was he able to gather evidence which said not only that the heliocentric system was true, but that the geocentric system could not be. Galileo's data proved that theory false, and it took about a century for the scientific community to catch up, but catch up they did. In the case of the planet Vulcan, well, this theory was developed when French astronomers measured the orbit of Mercury with the greatest precision ever. It was an amazing feat of scientific and technical achievement. It was astounding. And they found that, gee, the orbit of Mercury wasn't correct. It wasn't following Newton's classical laws of gravitation and orbits. Those laws set out by Newton and Kepler. Mercury was just deviating by a tiny amount, but the deviation was there. Scientists and astronomers spent the next 2 centuries trying to find Vulcan. Now, folks will tell you that, oh, Albert Einstein proved Vulcan didn't exist, but that's not true either. Albert Einstein came forward, as Milgram did, and said, I have a different theory of how Mercury works. Nobody believed him at first, and yet Eddington, the great English astronomer royal, decided, this might have merit, and he sponsored the idea of an eclipse expedition to find Vulcan, or not, and measure the deviation of Mercury. It turned out that these experiments showed that Einstein's theory was indeed right, and his gravitational ideas demonstrated exactly how Mercury was moving and changing, and in fact, Vulcan became not only irrelevant and unnecessary, but it just wasn't there. Well, we take a look at the present day with MOND, Modified Newtonian Dynamics, a different theory of gravity that, like Einstein, modifies Newton's ideas. Well, gee, Einstein could tell you. When you say, hey, the smartest guy on the planet for over 400 years, he was wrong. His theory has flaws. Well, you're either a great genius or a complete kook. In Einstein's case, we know which side he was on, and not because we like him or his theories, but because they work, because they generate predictions which are verified by experiment. Now, Vera Rubin came up with the discovery that galaxies, well, the stars don't orbit in Keplerian manner. They don't follow classical Newtonian dynamics. Instead of a Keplerian situation, as we have with our solar system, where each planet farther out orbits more slowly and takes more time, Vera Rubin found that the velocities for stars orbiting galaxies maintain a great deal of consistency from quite near the core to very, very far out. And scientists over the decades have reconfirmed her work and proved her ideas were true. Galaxies do exhibit non-Keplerian rotation. The theory for this was there must be a large shell of massive material. A large shell, a halo of material, would indeed change the way stars orbited galaxies because of all this mass on the outside, and they would indeed explain these orbits. Does that mean that it's true? No. To prove the ideas of dark matter, we must find it. Like luminescent ether, like the planet Vulcan, we've been looking for a long time. Every experiment has come up empty-handed. No one yet has found dark matter. Now scientists keep saying, oh, we're narrowing the parameters. We're restricting the space where we can possibly find dark matter. This is good scientific work, and I have nothing against it. But the problem is you keep coming up empty-handed. In fact, when you keep finding something isn't there, you get to a situation where you have to go, is dark matter really there? Or are we not finding it because it isn't there? And unfortunately, we have no experimental method. No genius of Galileo's caliber has come up with a new instrument and a new experiment to definitively settle that question. Now, is MOND popular? No. Do great numbers of astrophysicists flock to the MOND banner? No. It's seen as kind of a flaky outside idea. Does this matter? Certainly not. Science isn't about poll numbers or popularity. Again, ask Galileo. The heliocentric system was so unpopular it was actually considered heretical. Espousing the heliocentric system could have gotten you in grave trouble in 16th century Europe. Well, we don't persecute people who support the wrong theory anymore. We just say, as good scientists, bring me the evidence. And in fact, so far, there is no definitive experiment that has been done which either says, number one, either of these theories, we have found definitive evidence that that theory cannot be true. How would we do this? I'm at a loss. If I knew, I'd go ahead and propose the experiment and collect my Nobel Prize. But in fact, we haven't got data, physical evidence, which says the great galactic halos actually exist, nor do we have any evidence of what dark matter particles actually are. We've had a large variety of possibilities over the decades, each of which have been, I'm afraid, destroyed in turn. The evidence hasn't supported them. So right now, we, like the people in Galileo's time, are stuck with two competing theories, but not a great deal of evidence to help us choose between them. There's a great tendency to say, this is popular, that's the banner I'll flock to. So many people believe it, it must be true. I'm sorry, nature has no obligation to go ahead and fulfill your wishes or confirm your pet theories. We as astronomers, as scientists, do have an obligation. However, we are under obligation to be humble before the evidence, to test and test again. If it's really scientific, if it's really true, anyone should be able to repeat the experiment. Anyone should be able to go ahead and verify our data. We publish and we stand up in the full scorching light of scientific inquiry and skepticism, and we say, here I stand. This is my data. Disprove it if you can. Knock that chip off your shoulder if you're a big enough fella. Go ahead and give it a try. But right now, friends, as interesting as the dark matter theory is, and as interesting as the MOND theory is, we don't really have that crucial scientific data, that verifiable evidence that either one of these theories are true. We sit in this uncomfortable Schrodinger's cat-like demi-state where we have two conflicting ideas that can't both possibly be true, but how do we choose between them? Sometimes these things simply take time. If we were living in, say, 1350 and looking at the two great systems, as Galileo said, the exploration of the two chief world systems. That's the way he put it, the heliocentric and the geocentric. But until Galileo built his astronomical instrument and gathered his data, there was no definitive evidence to knock out one theory or the other. In fact, when Galileo used his telescope and showed members of the political elite and the church elite through his telescope phases of Venus, the moons of Jupiter, and other things, a very famous cardinal looked through the eyepiece and stood up, and Galileo's like, I see, but I do not believe. This fellow is a reminder to us to be humble before the evidence and not to trumpet our successes in popularity as successes in scientific fact. And with that, friends, I'll happily turn you back over to Scott and all our Global Star Party friends, and good luck, and I hope everybody has clear skies for the Perseids this week. It's not looking good for my house, but I hope you get a great view. Thanks, everybody, and good night.